so this is basically a crash course of dermoscopy to kind of give you the essence of it and give you a flavor. And it's going to be a ton of information, and I'm going to try to get through as much as possible before you guys say, listen, you know what, I can't take any more. With that said, let's just go quickly through a little bit of the introduction. And historically, something very interesting happened in the late 1700s with a physician by the name of Joseph Planck in Vienna. And what he did, in a way, is kind of revolutionize the way we think about skin disease. And that is that he is the first one to actually categorize skin disease by its primary morphology. So looking at things that are macules, vesicles, bulla, et cetera, and this is the first time in the history of derm that diseases were categorized by primary morphology. Then Robert Willen, who continued that work, also basically categorized disease by primary morphology, and all of the images that were drawn again, kind of highlighted this issue that if you knew the primary morphology, you would know what the disease is. So now if anybody tells you you have a pearly papule with arborizing telangiectasia, that's primary morphology, it's a basal cell. If somebody says, you know, I have a cluster of vesicles on an erythematous base, I mean, right, everybody says herpes. So that was really their work that made us aware of that. And so in essence, what dermoscopy is, it's another way of looking at primary morphology, and it has done multiple things. One, it has re-engaged us in the process that, yes, primary morphology is important, which many of us had forgotten. And two is it allows us to see a different type of primary morphology, which is subsurface morphology, and that morphology has given us a better diagnostic accuracy overall when evaluating a lesion. And so we have clinical morphology, which, for melanoma, let's say the ABCD. Then we have dermoscopic morphology, that's what we'll be talking about. Confocal, which you heard about earlier today. It's kind of fuzzy cellular or quasi-histology morphology. And then you have histopathology, which is, again, just another form of morphology on the cellular level. And there are now two types of light sources that are utilized for dermoscopy. One is standard light, so non-polarized, and the other one is polarized dermoscopy. So those are the two. And it turns out that the two are not equivalent. So it is important for you to have some sense of what is occurring with these two different light sources. So standard non-polarized dermoscopy, and these are the different companies that produce those scopes. The physics behind it is as follows. So you have light that hits the stratum corneum, and almost all of it bounces back, and you don't see anything below that level, and that gives you your image. And again, schematically here, light bounces off, nothing seen below that surface, and that's your clinical image. When you add a liquid interface to this on top of the skin, so whether it's alcohol, ultrasound gel, mineral oil, and then you apply a glass plate and a light source, that's basically now your standard dermatoscope, okay? And with this, here's your glass plate, there's a liquid interface in between. Now, light can penetrate past the stratum corneum before it bounces off a structure and comes back. And those are the structures that you're now able to see with standard dermoscopy. And so if the light hits the DE junction that's pigmented, then you will see a network pattern on the skin. If the light comes in contact with, say, a cluster of nevus cells, then you'll see globules. And if it encounters blood vessels along the way, then you'll actually see the vascular morphology under dermoscopy as well. So you have your clinical view and dermoscopy, now another degree or another level of morphology that you're seeing. Now, polarized light is a little bit different. With polarized dermoscopy, you don't have to touch the skin, and you don't have to use a liquid interface. So you can actually just use the scope without touching the skin and no interface whatsoever and get a dermoscopic image. With that said, wetting the skin is going to give you a clearer dermoscopic image, and if you actually touch the skin with the liquid interface, it just makes it a little bit crisper. The images are just a little bit sharper. Again, you don't have to do the liquid interface and you don't have to touch the skin, and there are advantages to that. And the way that polarized dermoscopy works is as follows. So you have a non-polarized light that goes through a polarizing filter, so now you have polarized light. And if your cross-polarized filter, so the second filter, if they are not parallel to each other, so the light and the filter, then this light will not pass through that second filter and you see nothing. It's black, okay? However, if this polarized light here interacts with something in the environment that causes the angle of polarization to change, called randomization of polarization, then that light that now is in parallel to the filter will come through. And that's the essence of polarized dermoscopy. And so here's what happens actually. You have a polarizing filter here, and you have a cross-polarizing filter. Now, light that bounces off the stratum corneum doesn't change its angle. The polarized light doesn't change its angle, and therefore it cannot pass through the cross-polarized filter. Now, if it is able to go a little bit deeper into the skin, it still does not change enough of the angle of polarization, and it doesn't get through the cross-polarized filter. However, if it interacts with enough structures and goes deep enough into the skin, then, and it changes its angle, then it passes through the cross-polarized filter and you can see the structures. With that, you should now already be it should be intuitive that polarized light is blind to the top layer of the skin, okay? And so the first 0.06 to 0.1 millimeter of skin, polarized light is not very good at seeing, okay? But in the trade-off is that you can see deeper into the skin, so you can actually see more of the vascular structures and more of the collagen structures in the skin, and you'll see in a moment why that is important. So, in essence, the two scopes, non-polarized and polarized dermoscopy, they're not the same. When it comes to melanin, right, pretty much the same. With polarized light, standard light here and polarized, but the melanin will appear a little bit darker. It'll be a little bit richer in its color under polarized light. Again, you're getting different depths of melanin that you're seeing with the polarized light. The deeper melanin will appear also different. So in standard dermoscopy, the plays of hue in the blue range will be pretty flat. You won't have a lot of fluctuation because it doesn't go deep enough. With polarized light, just hopefully you can appreciate the different plays of the bluish hue with polarized light. Because you're seeing the deep melanin as well as the superficial, whereas in standard dermoscopy, you're seeing more of the superficial melanin, not the deeper melanin. And we looked at this, and again, under standard dermoscopy, the things that are better seen as compared to polarized is blue-white veil, and we'll get to that in a little bit, peppering, which represents regression, and your milia cyst. Again, milia cysts are sitting up high in the skin, and therefore you will see them with standard dermoscopy. Now, with polarized light, the things that you see better are the reds and pinks because you're seeing the vascular component of the lesion better. The shiny white streaks, which is collagen, so you will see that better, actually almost exclusively, and you'll see your blood vessels better with polarized light. So here is a melanoma. Here is standard dermoscopy, and here's polarized, right? Under standard, there's very little other than just this tan pigment. But under polarized, you can see the entire vascular blush, the entire vascular volume within this lesion. So some kind of a neoangiogenic process in a tan lesion, right? Here is another melanoma arising in a dysplastic nevus. Here is standard dermoscopy, and you can very little of the vascular blush. And notice here, with polarized, you can see not only the the vascular blush, but you can also see the individual vessels within the melanoma. Now, there is obviously a compression issue here. So you only need about 10 millimeters of mercury pressure to blanch out the vasculature in the skin. So if you use a contact non-polarized scope, you have to put a liquid interface and you got to press down to get the air bubbles out, right? If you have air bubbles in there, you're not seeing dermoscopy, because if there's an air interface, you're not getting below the stratum corneum. So you have to get rid of the air bubbles. And when you're doing that, you're putting pressure down and kind of blanching out some of the blood vessels, and so more difficult to see. If you use an ultrasound gel, then you can just very gently put the scope on the gel, no air bubbles then, and you can now sort of appreciate a little bit of the vascular blush more. And then when you use polarized dermoscopy without touching the skin, there's no compression at all, and now you can see the vascular blush. And notice all these individual linear vessels in here as well become very conspicuous. Now there's one structure that is more conspicuous with non-polarized dermoscopy, and that is the Melia cyst. So here is a seborrheic keratosis seen with standard dermoscopy and with polarized dermoscopy. Now, you can already predict that if you were only to look with polarized, that you will overcall some seborrheic keratoses as possible melanomas, and that's exactly what has occurred. So with polarized light, your specificity is not as good. You tend to do, you remove more septares than you would with standard dermoscopy, and that's because the Melia cyst, which is a very important clue, is missing with polarized light. And to make that point a little bit stronger, we're going to show you a video in a second. And so I am toggling, I have a scope that allows me to toggle between polarized light and non-polarized light. And so we are starting looking at this image with polarized dermoscopy. And now if you start the video, you will see as I toggle, you'll see the Melia cyst come in and out of view. Yeah? We don't need the sound, but that's okay. So again, that's showing you that you can really only see the Melia cyst with standard dermoscopy. Polarized light, you can't, and that is indeed a seborrheic keratosis. And again, the explanation for that is your Melia cysts are sitting up high in the skin. Polarized light doesn't penetrate, doesn't change its angle of polarization at that depth, and therefore it's blind to these structures. You won't see them. Now, there's one structure that can only be seen with polarized light, and that is known as the crystalline structure. And so here, in this case, it's a dermatofibroma. And here is standard dermoscopy polarized, and notice these white lines here. These are your crystalline structures, and only seen with polarized light. And again, to make that point, here's a hypomelanotic melanoma. This is with polarized light, so you're seeing these strands, these white streaks. And now if we play this video, you'll see that as we toggle between, you'll see how they'll come in and out of view, okay? So the crystalline structure can only be seen with polarized light. Now, in addition, your blue-white veil, which is due to orthokeratosis, and all of that, we'll go through this again in a moment, but it's due to the orthokeratotic component, is seen better with standard dermoscopy, and you can already predict why. Yeah? So orthokeratosis is sitting up high, so if it's contributing to the blue-white veil, you're going to see it better with standard light. Polarized light is going to go past that, and therefore it's not going to be a factor. So this blue-white veil here that you see, this is all due to orthokeratosis. Here the veil is not seen, but instead you're seeing the crystalline structures. Okay? So blue-white veil, and in this case, the crystalline. And again, to make that point, here is a nevus that's, so we are starting off with polarized dermoscopy, and if we can play it, you'll see how the veil becomes more conspicuous under standard. There. Yeah? So when that occurs, you already know, you can predict that on pathology you're going to see orthokeratosis. Okay? And again, the explanation now should be also obvious. You know, this is all sitting up high in the skin, and so polarized light is going to be blind to that layer of skin. Now, does it have any implications in clinic? Absolutely. Again, this was in a study setting that we looked at, where we wanted to look at the number of times the physician correctly diagnosed the lesion. So they were difficult lesions. And with that said, in the melanomas, more correctly diagnosed melanomas under polarized light. And a lot of that had to do with the fact that you could see the vascular structures and the crystalline structures better. And you can already predict your seborrheic keratosis, your diagnostic accuracy was much better under standard dermoscopy than it was under polarized light. And then in terms of confidence, your confidence in a diagnosis also is dependent upon what scope you use. Basal cell carcinomas, you're more, again, the lower score means more confident. So with basal cell carcinomas, you were more confident with polarized light. Again, why? Because you're seeing the vascular structures better. And in seborrheic keratoses, you're more confident in the diagnosis with standard dermoscopy because you're seeing the milia cyst better, right? So there are implications both on a diagnostic level and your confidence level. So bottom line is that your standard dermoscopy and polarized dermoscopy provide complementary information. And both of these scopes really need to be used in a way, right? So for you to get the maximum amount of information. So standard dermoscopy, superficial layers, polarized, deeper layers. And in the study we did, we posit the following, that standard dermoscopy increases your specificity, but polarized dermoscopy increases your sensitivity. So if you are screening for something, you want to have the highest sensitivity. Okay? So for screening purposes, polarized dermoscopy is actually ideal. But once you have identified a lesion now under polarized, for you to weed out the subcaries, for example, you would need to now look at standard dermoscopy. And so because of that, my preference is actually using a hybrid scope, where you have the ability to look at the lesion and then toggle with one button between polarized and non-polarized light. And so there are right now 3 hybrids available. 2 are made by the same company, Dermlight, and 1 is made by Canfield. But the one made by Canfield is only for your iPhone. So you have to put your iPhone, and then this acts as a video dermatoscope. So you're actually looking at the lesion on your iPhone screen, all right? But it allows you to toggle between polarized and non-polarized. So that's the only other one, and otherwise it would be this the company 3Gen that makes their hybrids.